Lighting plays a heavy role in architectural design. Depending on the chosen types and the placement, a beautiful room can still look bad with bad lighting, and a not so well designed space can look good with quality lighting. Good lighting quality is based on three pillars: human needs, energy efficiency, and architectural considerations. There are three types of lamps, each with its own subtype. First are the filament lamps. Second, the gaseous discharge lamps. And third, the high-intensity discharge lamps. Units of light. Unit of light, or the luminous flux, is measured in lumens. Unit of density of light is measured by Footcandle. This is the amount of lumens falling on an area per square foot. Lux is the amount of lumens falling on an area 1 square meter, 1 meter away. 1 Footcandle is equivalent to 10.76 lux. Unit of light intensity is measured in Candlepower, or candelas. Unit of brightness is measured in Footlambert. Incandescent lamps. It is composed basically of a sealed glass containing a filament connected at its ends to the contact area in the base, thereby completing an electric circuit. The glass envelope comes in a variety of shapes and sizes. Bulb designations consist of a letter to indicate its shape, and a number to indicate the diameter in eighths of an inch. These are the various shapes and their designated letters and numbers. This is a chart indicating the types of incandescent lamps and their following uses.
R and R lamps are complete optical system in a single bulb. The bulb contains a filament, reflector, and lens. R bulbs are lamps that has wide flood beams angles which provides more than a 45-degree or typically 120-degree angle when lighting an area, while par bulbs are lamps that have spotlight features which provides beam spread that is commonly lower than 45-degree, and it's best for outdoor security lighting.
Tungsten halogen lamps. The tungsten halogen, also known as quartz iodine lamps, is an incandescent lamp that uses a halogen gas cycle to prevent rapid depreciation of the lamp filament and darkening of the transparent envelope. Fluorescent lamps. These are low-pressure mercury vapor gas discharge lamps that uses a fluorescence to produce visible light. It comprises a cylindrical glass tube sealed at both ends and containing an inert gas. Built into each end is a cathode, which supplies the electrons to start and maintain the mercury arc. This light is absorbed by the phosphorus, in which the inside of the tube is coated and is re-radiated in the visible light range. A ballast is required for all fluorescent light source. The ballast serves for supplying the high voltage necessary to start the arc and limiting the current in the arc after it is formed. For the operation of some fluorescent tubes, an automatic switch known as a starter is required in addition to the normal wall switch. Fluorescent lamps are classified according to shape and to the method of tube operation. For the shapes, we have standard, slimline, and circline, and for the method of tube operation, we have preheat, instant start, and rapid start. For the preheat, it requires a starter which preheats the cathodes so that less voltage is required to strike an arc. This class is also called a switch start or starter start lamp. While for the instant start, when the lamp is first switched on, a sufficient voltage is applied between the electrodes to strike the arc without preheating them. They have single pin bases, which are called slimline lamps. And lastly, the rapid start. These use low resistance electrodes which can be heated continuously with low current losses. These are the only fluorescent lamps that can be electrically dimmed or flashed. Mercury vapor lamps. A mercury vapor lamp is a gas discharge lamp that uses an electric arc through vaporized mercury to produce light. It contains mercury vapor in a clear quartz arc tube, which when electrically excited produces visible light of a blue-green color. They operate at an internal pressure of around 1 atmosphere and require special fixtures, as well as an electrical ballast. It is suitable only for limited industrial areas, general outdoor applications, and street lighting. It is often used in streets, gyms, banks, or stores.
Metal halide lamps, a modification of the mercury vapor with an arc of improved color. In addition to mercury, the arc tube contains metallic vapor such as indium iodide, thallium iodide, or sodium iodide. It possesses, therefore, increased light output, improved color rendition without the use of phosphorus, and small source size. High-pressure sodium lamps are the newest addition to the HID field. Its arc tube is made of high-density polycrystalline alumina and contains a mixture of primarily sodium. Ballasts are auxiliary equipment for fluorescent and HID lamps which limits the amount of current in the lamp and provides the proper sorting voltages. A power factor is frequently listed with each ballast description. The low power factor ballast is cheap and inefficient, while the high power factor ballast has a capacitor which improves its efficiency. Capacitor is an electric component which consists of conducting plates insulated from each other by a layer of dielectric material, introduces capacitance into a circuit. Capacitance is the quantitative measure of the electric energy storage capability of a capacitor, usually measured in farads or microfarads. To sum up their differences, here is a lamp comparison chart.
Luminaires or lighting fixtures is the device which supports the source or sources of electric light and helps to control the light rays from the source. Controlling the rays is necessary to secure even distribution, to avoid glare, to cause direct rays to the eye, and eliminates disturbing reflection of the rays from polished surfaces. The following are examples of luminaires, such as the ceiling-mounted downlights, spotlights, pendants, wall lights, task and table lights, floor lights, fluorescent fittings, oddities, and exterior lights. Classifications of luminaires. Indirect. 90% to 100% of the light output is directed towards the ceiling and upper walls of the room. Greatest control of brightness, efficient utilization of lights depends absolutely on reflection factor for ceiling and upper side walls. Semi-indirect. 60% to 90% of the light is directed upwards, 40% to 10% downwards. Provides good brightness control in the lower hemisphere and reasonable freedom from shadows. General diffuse or direct indirect. Provides approximately equal distribution of light upwards and downwards. Semi-direct. 60% to 90% of light is directed downwards, while 40% to 10% is directed upwards. Eliminates high contrast. Brightening of upper portions makes room larger and pleasant. Direct. 90% to 100% of the light output is directed downwards. Characterized by high utilization of filters in work plane, high contrast with surroundings, sharp shadows, and direct and reflected glare.
Lighting systems. There are three types of lighting systems. First, Cornice Lighting, a system where light sources are shielded by a panel parallel to the wall and attached to the ceiling to distribute light downwards over the wall. This is considered as direct lighting. Second is the Cove Lighting, a system where light sources are shielded by a ledge to distribute light upwards over the ceiling and upper wall. It is a form of indirect lighting. Third is the Valance Lighting, a system where light sources are shielded by a panel parallel to the wall, usually across the top of a window. This provides light both upwards and downwards over the wall.
Lighting methods. First, the local lighting. It is a method which employs lamps at definite points where light is especially needed, producing pools of light mingled with areas of shadows. It is very opposite of uniform illumination. The location of lamps in this method usually depends upon the position of furniture or the position of activity areas. Second, the general lighting. This method strives for diffuse light and uniform intensity over an entire area. The lamps are evenly spaced without regards to furniture location and are provided with reflectors, baffles or diffusing prisms to prevent glares, harsh shadows, and uneven illumination. Third, the combined local and general lighting, sometimes called localized lighting. This provides sufficient general lighting to illuminate various objects in the room and at the same time furnishes additional local lamps at desks, reading tables, showcases, and other equipment that needs additional illumination.
Factors which will achieve desirable seeing conditions. Intensity of illumination. Intensity of light required will depend upon the tasks involved as follows. For casual work, as in conferencing, interviewing, and in active filing, 10 to 30 foot candle. For moderate work, as in intermittent filing and general clerical work, 30 to 50 foot candle. For prolonged work, as in active filing, index referencing, and mail sorting, 50 to 100 foot candle. For precision work, as in accounting, auditing, tabulating, bookkeeping, business machine operation, reading for productions, and rough layout drafting, 100 to 150 foot candle. For fine precision work, as in cartography, designing, and detail drafting, 150 to 200 foot candle. In terms of quality of light, light distribution depends upon uniformity, freedom from variations of illumination in a room or space. Absolute uniformity signifies same intensity throughout, and it is not always practicable to attain. A deviation of 25% from the average intensity cannot be detected by the eye and is considered an acceptable maximum. Diffusion. Diffusion refers to the number of directions and angles from which illuminating rays proceed. Good diffusion is obtained when light falls upon a matte or satin surface from a variety of directions, thus eliminating shadows and streaks of brilliancy. Poor diffusion results from illumination from one direction only, thus causing visual confusion because of distorted highlights and shadows. The third factor, absence of glare. Glare is defined as the effect of brightness in the field of vision which causes annoyance or discomfort, or in worst cases, interferes with the seeing. When the glare is caused by light sources in the field of vision, it is known as direct glare or disability glare. When glare is caused by the reflection of a light source in a viewed surface, it is known as reflected glare or discomfort glare. Bare lamps or brilliant fixture globes should never be in the line of sight from any point in the room. An angle of 45 degrees between the horizontal and the line of sight, line from the lamp to the eye, is generally accepted as the greatest permissible angle. And lastly, color of light. Color of light depends upon the type of lamp chosen. Incandescent lamps provide yellow light, although there are many other colors depending upon the color of their gas bulbs. Fluorescent lamps have the greatest variety of colors, ranging from daylight to bluish white and even pinkish white. Color is also used to enhance certain qualities. For example, deluxe fluorescent lamps are used to enhance food in restaurants. For lighting terms, absorption. Loss of light when light rays strikes or traverses any medium. The ratio of light absorbed by a material to the light falling upon it is called the absorption factor or absorptance. Diffuse reflection. A beam of light is reflected diffusely. That is, its ray is scattered in all directions if it strikes a rough or matte surface. Specular reflection. A beam of light is specularly reflected when a light ray striking a shiny or glossy surface at an angle of incidence is reflected as the same beam with equal angle of reflection. Reflectance, also called reflection factor. It is the ratio of light reflected by a surface to the light falling upon it. Transmission is the passage of light through a medium when light falls upon a transparent material. It is refracted, bent as it passes through the material but emerges at the same angle that it entered. When passing through a translucent material, such as plastic, and the emerging rays are spread in all directions, it is called diffused transmission. Transmittance, also called transmission factor. It is the ratio of light transmitted to light striking the surface. Accent lighting, directional lighting to emphasize a space or an object. Downlight, a fixture producing concentrated direct lighting from a single bulb. It may be recessed in or mounted on the ceiling. High hat, a term often applied to a can type of recessed incandescent downlight. Eyeball, recessed or semi-recessed lighting unit with a rotating spherical element that may be turned to project light in any direction. Lumiline, a tubular fluorescent lamp with a disc base at each end. Luminance Ceiling, a false ceiling of diffusing material with light sources mounted above. Filter, device which changes either amount or the color or both of light passing through it. Dimmer, a device to control the amount of light by reducing the voltage or the current, also called a rheostat. Capacitor, an electric component which consists of conducting plates insulated from each other by a layer of dielectric material. Introduces capacitance into a circuit. Capacitance is the quantitative measure of the electric energy storage capability of a capacitor, usually measured in farads or microfarads. For the lighting symbols, tree or building mounted adjustable fixture, stake mounted adjustable fixture, junction box mounted adjustable fixture, below grade fixture, wall mount sconce, pendant, path light, step light, pedestrian light, street light, bollard, incandescent strip light, junction box, single pole switch, low voltage dimmer, three-way switch, three-way dimmer switch. Lowercase letter denotes control group. Center line, to be determined. Numbered note. Detail. Section. Fixture type identification.